Assalamualaikum, my name is Aleena and roll number 21DE35. In this video, I tell you about the adaptive filters and its applications. First of all, what is adaptive filters? An adaptive filter is a digital filter that self-adjusts its coefficient to optimize its output in response to changes in its input or environment. It continuously updates its parameters based on the specific algorithms, such as least mean squares and Vernier filters. We discuss its two algorithms. First, least mean square adaptive finite impulse response filters, and secondly we discuss Vernier filters. First, least mean square adaptive filters. What is least mean square adaptive filters? The least mean square adaptive filter, also known as LMS, adaptive finite impulse response filter, is a type of adaptive filter that adjusts its coefficient uses the LMS algorithms. It has a finite number of taps, coefficients, and time to minimize the mean square error between its output and the desired signal. Okay, I again tell you, it has finite time to minimize the mean square error between its output and the desired signal. It makes this effective for applications like noise reduction, echo cancellation, and equalization, where the filter needs to continuously adapt to changing input conditions. Now this is graph about spectrum for using adaptive filters. In this graph, it tells about the relation between noise spectrum and desired signal spectrum. And this is the block diagram of simple noise considered using a one-type adaptive filters. The DSP system consists of two analog to digital conversions. ADC channels. The first microphone with ADC is used to capture the desired speech. However, due to noisy environment, the signal is quantized and the ADC channel produces a signal with the noise. Here we have Dn is equal to Sn plus n of n. Okay, and this is the block diagram. This tells that the signal and noise relation of adaptive filters. Now this is the formula of adaptive filters, LMS, least mean square. We put values from this table as you show here. N of 0 is equal to 0.3 and we put 0.3 here. Now the next type is Vernier filter theory and least mean square algorithm. This is the block diagram of Vernier filter for noise cancellation, and here is the formula of this. In this example, we take firstly derivative of this and then W is equal to 1. Put in this derivative and we have answer 30. Example 10.2 is same as 10.1, and in the last we have. And now I tell you about the applications of adaptive filters. There are three applications of adaptive filters: noise cancellation, system modeling, and the line enhancement. First of all, noise cancellation. What is noise cancellation? Noise cancellation using adaptive filters is a technique where an adaptive filter is used to reduce or eliminate unwanted noise from a signal of interest. Here is the block diagram of noise cancellation. And the next system modeling. And the next application of adaptive filters is the system modeling. What is system modeling? System modeling in adaptive filter involves describing the relationship between inputs, outputs, and the behavior of the adaptive filter itself. Okay, it tells about the relationship between inputs, output, and the behavior of the adaptive filters itself. Here is a block diagram, and then we have the last application of adaptive filters is enhancement in adaptive filters, line enhancement. This one, line enhancement using adaptive filters is a signal processing technique aimed at isolating or enhancing specific components or features within a signal. This is line enhancement using an adaptive filters block diagram. And this is the graph of noisy signal and enhanced signals that tell us about the number of samples. Line enhancement using adaptive filters adjusts of filter parameters to selectively enhance specific features within a signal, improving the interpretability and usability of the processed data in various applications. This is all chapter 10 about adaptive filters.